Hello, today let's talk about some basic statistics, how to estimate the mean, variance, and the standard deviation. For example, we collect some sample data. You can see at the bottom there are lots of dots there. If we want to fit a normal curve to this histogram like this, then we need to calculate the population mean and the population variance or population standard deviation. Statisticians often use the symbol x bar to refer to the estimated mean, which is also called the sample mean. And they use the Greek symbol mu to refer to the population mean. Here is an example. The population mean, maybe mu, is different than the sample estimated x bar. So the estimated mean x bar, you can see here, is different from the population mean mu. But with more and more data, the x bar should get closer and closer to the true population mean. We will now determine how wide to make the curve by calculating the estimated variance and the standard deviation. To get the mu, like the average, after that, we have to think about the shape or the width. We want to calculate the data, how are they spread around the population mean. So the population variance is x minus mu, get the square, and divided by n. The standard deviation, we just get a square root of the population variance. That's the formula. For estimated population, we just change the mu to x bar to get the population variance and the population estimated standard deviation. Because we almost always work with a relatively small sample and not the entire population, this is the formula we will use most of the time. The difference is here is divided by n minus 1, and if you compare here, it's divided by n. We can talk about that why it's minus 1 in future. For the population mean, it's just the sum of the measurements divided by the number of measurements. We get the average measurement. The population mean, also you sum of the measurement, get the number of measurement. This is just the estimate of the population one. For the variance, we also mentioned that divided by n minus 1. Compensate for the fact that we are calculating difference from the sample mean instead of the population mean. So we want to consider that. We use a smaller denominator here. In this example, when we get the x bar, it's kind of a little bit smaller than the true mean 20. And when we calculate the estimated variance, this is the formula what we get. So for the 81 is less than the true population standard variance or population variance 87. So in this case, if we do it by n minus 1, then maybe it get closer. So when we use the sample mean, we underestimated the variance we got with the population mean. That's why we divide by a smaller number to make it more towards the true value of the population variance, because for the mean, it's smaller. And here is example. What is the corresponds to the sample mean x bar here? And after we calculate a lot, we get like a bottom of the one. Then we multiply everything by derivative of x minus v, which is negative 1. The derivative of x, which is respect to v, is 0, and the derivative of minus v is minus 1. Here is a formula how to get the derivatives. The derivative corresponds to the slope of the purple line here. And we also want to find the value for v such that the slope of the purple line equals 0, because that is where we find the minimum variance. Here is a formula of the derivative. Let's also explain why we do not use the absolute value here. Okay, so this is a brief introduction about the statistics, mean, variance, and the standard deviation. Thank you for watching.